Welcome back. In the second part of this lecture, we'll be talking about graphing transformed sine and cosine functions. Now, before we graph our sine and cosine functions, we can do a little bit to simplify them using some properties that we know about our trig functions. So for example, I say here that if you were giving me 5 cosine of negative 3x, that instead I would be graphing 5 cosine of positive 3x. And the reason why I know that they have the same graph is because cosine is an even function. Because cosine is even, remember that that means that cosine of negative x and cosine of positive x would be equal to each other. So 5 cosine of negative 3x should be equal to 5 cosine of positive 3x. And similarly here, if you gave me negative 2 sine negative 4x, I would instead graph positive 2 sine positive 4x. And the reason I know that I could do that is because sine is odd. And because sine is odd, that means, remember that an odd function has the property that f of negative x is negative of f of x. In other words, you can take that negative outside and it's still equal. So if we're thinking about negative 2 sine of negative 4x, I can take that negative out, and that gives me positive 2 sine 4x. So that's something that I'll be doing to help save myself a little bit of work. Because if you're thinking in terms of transformations, for example, this negative 3x, this would be both a horizontal compression and a reflection around the x-axis, or around the y-axis rather. But for the other one, this would just be a horizontal compression. I have one less operation to worry about. So it saves me a little bit of time if I simplify my functions first. Now, you could think in terms of transformations if you're graphing these trig functions, but we're going to instead use the method of key points. And when I say key points, I'm referring to, for each period of either the sine or the cosine function, the 5 points that basically describe that function, where it's at its maximum value, where it's at its minimum value, and the points in between where we're at the x-axis. Those would be, for example, for my sine function, the 5 key points. And if you were thinking about the cosine function, same sort of thing. The 5 key points from one cycle, those are the points where we are at our maximum value or our minimum value or in the middle. So what we're going to do then is start by figuring out where are these 5 key points, and then once we have the 5 key points, we'll be able to graph our function. So the idea here is we're going to first start looking just at these simpler kinds of transform trig functions. So you'll notice there's no horizontal shift, there's also no vertical shift going on here. We just have a horizontal stretch and a vertical stretch. We're making one little side condition here to make our life easier, that b is positive. So we're imagining that we've already used the odd or even properties of our trig functions to rewrite them with a positive value for b. And so that when I'm finding my period, I don't have to divide by the absolute value of b anymore because b is already positive. So I found my period, and once I've got the period for this transform trig function, then I'm going to take that period and slice it into 4 equal-sized pieces. And once we've done that, that would be the x-coordinates, or those would be the x-coordinates for those 5 key points. So that's the idea here, is that we're going to start at the x value of 0 and go up to the x value of whatever our period is and slice that into 4 equal-sized pieces. And once we have the x values, then all we need to do is figure out what our y values are. Remember that for y equals sine of x, if you were thinking about what would be the y values for the 5 key points, it would be first 0, and then 1, and then back to 0, and then back to negative 1, and then back to 0 again. If you had a number in front, that would be multiplying those y values by that number. So instead of 0, then 1, then 0, then negative 1, then 0, if we had a times sine x, it would be 0, then a, then 0, then negative a, then 0. And we could say similar sorts of things about cosine, that for the 5 key points, the y values would be a, then 0, then the opposite of a, then 0, then back to a again. Okay, so what we'd like to do is sketch 2 cycles of our graph of y equals 2 sine negative 5x. And I know that since 2 sine negative 5x is equal to negative of 2 sine positive 5x, I know that I can graph this instead, and it will have exactly the same graph as the given function. And of course, the idea here, what I'm using is the odd property of the sine function. Since sine is odd, then that means that the negative inside that negative 5x, I can take that negative outside and I'll have something that's equivalent. So instead of positive 2 sine of negative 5x, I've got negative 2 sine of positive 5x. And next thing that I'll need to do is figure out what my period is, and the period should be then sine has a period of 2 pi, and it's sine of 5x, so divided by 5. So my period then is 2 pi over 5. Okay, so we're pretty much good to go. We're ready to start finding our x-coordinates for our 5 key points. So the idea again is that we're taking on our x-axis that interval from 0 up to, in this case, 2 pi over 5. And we're going to slice this into 4 equal-sized pieces. And so the idea here, of course, is if you have that length of 2 pi over 5 and you want to cut it into 4 equal-sized pieces, then the length of each piece, or the length of each subinterval, should be that full length of 2 pi over 5 divided by 4, or same thing as multiplied by a quarter. And that simplifies to give me pi over 10. So now I can start thinking about getting my x-coordinates. So one thing you'll notice here when I do this, I'm not going to be taking these values for x and rewriting them in terms of degrees and then going back and turning them back into radians after. I'm going to stay in radians throughout. So although it might feel not totally comfortable right now to think about things in terms of pi over 10, you might feel more comfortable thinking in terms of degrees. Follow along because I'm going to stay in radians throughout, and actually this simplifies my calculations a little bit. Pi over 10 is the length of each subinterval. So if I'm starting at the x value of 0, then for each x value I'm going to go up by pi over 10. So the next x value should be pi over 10, and the next one after that should be 2 pi over 10, which is the same thing as pi over 5. Then the next one after that should be 3 pi over 10, and then 4 pi over 10, and so on. And so this is actually a little bit easier. I don't even really need to think about what exactly are these angles in terms of degrees. If I'm just thinking about the fact that my tick marks on my x-axis will be pi over 10 apart from each other, then I know that my tick marks are 0, pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10, 5 pi over 10, and so on. And as far as the y values go, reminder that we're talking about this function that we have here, negative 2 sine of 5x. And remember that for sine, the y values would be 0, whatever the coefficient is, 0, the opposite of whatever the coefficient is, then back to 0 again. And since our coefficient is negative 2, we're going to start with 0, then the coefficient, then 0, then the opposite of the coefficient, then back to 0 again. And so there we go. We've got our 5 key points. So this is telling us 2 things. Number 1, when I'm setting up my x and y axis, I know that my tick marks on the x-axis will go up by pi over 10 each time. That's number 1. And number 2, I know that on the y-axis I'll need values as large as positive 2 and as small as negative 2. So let's get ourselves started. And I've got my tick marks already set up for me. So putting in what I have, my first point was 0, 0. Then we had pi over 10, negative 2. Pi over 5, 0. 3 pi over 10 with positive 2. And 2 pi over 5 with 0. So that means that one cycle of my trig function looks a little bit like this. And of course, I should be labeling these points. So the points 3 pi over 10, comma 2, and the point pi over 10, negative 2. Both of those points need to be labeled. The other three key points, they're on the x-axis, so they're good enough as they are. And now we just need to replicate this. Remember that sine is a periodic function, so what we see over here is going to be repeated over here. So we'll have that the y values will be such that we'll continue that pattern of oscillating, of going up then down, then up then down. And there we go. So I'm just going to label these last 2 points that I have, negative pi over 10 and positive 2, and negative 3 pi over 10 and negative 2. And I'm just going to label this, and I'm going to label this with the original equation. So although this is negative 2 sine of positive 5x, it is the same thing as the original function we were given, 2 sine of negative 5x. And so that's what I'm going to label that one with. All right, let's do another couple ones. So here we've got a cosine function, and I know that cosine is an even function. So I know that cosine of negative theta and cosine of positive theta, that those are equal to each other. So that means that for this function that we've got here, negative 3 cosine negative x over 2, which you could think of, if that makes it easier for you, as negative a half x, that would be the same thing as negative 3 cosine of positive half x. And so that means that for this cosine function, the period should be 2 pi divided by a half, which is the same thing as 4 pi. So first thing that we do, again, always start by simplifying our trig function if we can, and we were able to here. And then next, figure out what our period is. And once we know what the period is for that trig function, we need to then figure out the length of our subintervals. And we do that by taking that period and slicing it into 4 equal-sized pieces, dividing by 4 or multiplying by a quarter. And so the period here of 4 pi, when I slice it into 4 equal-sized pieces, that is pi. So that means that for my x values, we're going to start at 0 and go up by pi each time. So 0, then pi, then 2 pi, then 3 pi, and then 4 pi. And for my y values, this is again where we're going to need to go back and remind ourselves that when we were talking about the cosine function, that the y values for our key points were whatever the coefficient was, then 0, then the opposite of the coefficient, then 0, then back to our coefficient again. So if we're looking at what our y values are, here the coefficient for the cosine function is negative 3. So we start out with negative 3, then 0, then the opposite of it, then back to 0, then back to negative 3. So I've got my 5 key points, and I'm going to set up my x and y axis and get all those points plotted and then graph my function. So we have our tick marks are going up by pi, and also notice, of course, once you figure out the tick marks on the right side of the x-axis, it's the mirror image of those on the left side. If it's pi, 2 pi, 3 pi, 4 pi on the right side of things, then it's negative pi, negative 2 pi, negative 3 pi, and negative 4 pi on the left side of things. And away we go. We had for our y values, they were 3 negative when x was 0, then 0 at pi, then at 3 for x being 2 pi, then back to 0, then back to negative 3. And then we're just repeating ourselves for the second period. So again, just oscillating away, going from negative 3 to 0 to 3 to 0, and then back to negative 3 again. And we just need to label our points. All of the key points that we have that aren't on the x or y axis at a tick mark, those will need to be labeled. So negative 4 pi, negative 3. I'll have negative 2 pi, positive 3. I've got positive 2 pi with positive 3, and I've got 4 pi, negative 3. So those points need to be labeled. And then I just need to label my function somewhere. This was negative 3 cosine of negative x over 2. That was the function that we were graphing. And there we go. Now, if you're thinking about a vertical shift, so if we have a trig function where it's a sine or a cosine function plus k at the end, then it's easy enough to do. Basically, we'll do the same thing that we did for the previous, get our 5 key points, ignoring the vertical shift for now, and then once you find your 5 key points, then apply the vertical shift by adding k to the y values for all of our 5 key points. And then there we go. That's pretty much it. There's nothing really terribly exciting here. It basically starts out exactly the same way, and then we just have to do a vertical shift at the end. So here we're looking at this graph of 2 sine negative pi x plus 1, and I know that if I'm thinking about 2 sine of negative pi x plus 1, that's the same thing as negative 2 sine of pi x plus 1. So that's the function that I'm going to think about. But before I get to there, I'm going to first start out by looking at the function without the vertical shift. So I'm just going to look at y equals negative 2 sine of pi x. And I'm going to find out what the period is for that. And that should be 2 pi divided by pi, which turns out to be 2. And you can find out next that the length of your subintervals should be a quarter of that, taking that period and dividing it into 4 equal-sized pieces. So our subintervals go up by a half. So that means that for the x values for that, y equals the negative 2 sine of pi x, that the x values will all go up by a half each time. So we'd have them as 0, then a half, then 1, then 3 halves, and then 2. And for our y values, remember that for the sine function, the y values follow in the order of 0, then the coefficient, then 0, then the opposite of the coefficient, then back to 0 again. And here the coefficient is negative 2, so our y values should go from 0 to negative 2 to 0 to the opposite of it, then back to 0 again. So those are the 5 key points without the vertical shift. And so that means for the function with the vertical shift, we just have to add 1 to every y value, because for that vertical shift, that's just taking us upwards by 1 unit. So we just need to add 1 to everybody. And there we go. Our y values should be 1, negative 1, 1, 3, and 1. So those are the plot points that I'm going to plot. And then once I've plotted those points, I'll be able to connect the dots to come up with one cycle. And then I just repeat that to come up with my second cycle. And then life is good. So I'll start plotting my points, starting at 0, 1, a half, -1, 1, 1, 3 halves, 3, and 2, 1. So we have our sine function that's been shifted up by 1. And there we go. I'm just going to zoom in here so I can do a little bit of labeling, because all of these points, except for the one that's the y-intercept, they're all going to have to be labeled because none of these are on the x-axis at a tick mark, so they will all need to be labeled. So let's see, we've labeled 1 half, -1, 1, 1, 3 halves, 3, and the last point, which was 2, 1. And we're just going to repeat this pattern on the other side. So from this point 0, 1, we're going to, I'm just going to draw that a little bit better. There we go. So we're going to start with a y value of 3, then back to a y value of 1, then back to a y value of -1, and then back to a y value of 1. And there's my second cycle. And I just need to label that, all of those points. And there we go. So I have my function graphed, and now I just need to label this. This is the graph of y equals 2 sine -pi x plus 1.